All right, welcome back, everyone. Today we are doing Unit 5, Lesson 4. Just have uploaded a formula sheet for everyone with all the trig identities that are, shown here. So these may not be the majority of the ones that you will require. All right, that being said, let's start with today's example. Okay. Example 1, using your sheet of all identities learned in this unit, prove each of the following. It's pretty straightforward. Left hand side is sine 2x over 1 plus cos 2x. And this is obviously just tan x. I'm going to convert this into sine x over cos x. And let's see, what can we do here? I'll give you a hint. Whenever you have cos 2x, try to, convert it into one of its identities. Cos 2x is equal to this, or this. It's up to you which one you want to use. I am going to use this one. 2 squared x minus 1. So was it minus 1 or plus 1? Hold on. Yeah, minus 1. All right, did it. And whenever we have sine 2x, obviously use that to convert it into its thing. That's 2 sine x cos x. Now, the reason why I chose the minus 1 is because 1 and 1 will just cancel out. And then, because that's gone, we're just left with this and this. And now you can cancel out the 2's. And there's a cos x here, and there's a cos squared x. So one of the cos x's cancel out, and that's just equal to sine x over cos x. That's it. And left-hand side is equal to right-hand side. Pretty straightforward. Let us move on to example 2 now. Okay, example 2. We have proved that cos pi over 2 plus x equal to negative sine x. Well, I would use the example of a plus b, because this is what's happening. You're adding two angles, sorry. So what's cos a plus b equal to? Let's see. Cos, or x plus y, I guess. Cos x, cos y, sin x, sin y. And there's a minus sign in the middle. Since we know that pi over 2 is essentially 90 degrees, you can evaluate this. Now you can use radians as long as your calculator is in radians mode, or you can use degrees as long as your calculator is in that correct mode. So cos of 90 is what? Or if you remember from the graph, if you remember a unit circle, there's so many ways of doing this. You know that cos starts at a maximum, which is 0, and then 90, which is next checkpoint, is here. Then we have 180, and we have 270, and we have 360, and it goes like that. So at 90, it would be 0. Cos of pi over 2 is 0. And you just plug it into your calculator. You don't have to do what I just did. So that's just 0 times cos x minus sine x, and we know sine of 90, in case you could just plug it in, you can figure it out. It's 1. So that is equal to just, this is 0 because 0 times anything is done, and then this is minus nx. And there we go, we're done. Pretty straightforward. Let's try to do more. Example 3. Prove that cosecant 2x is equal to cosecant x over 2 cos x. Okay, let's see if we can do that. So we have a double angle and a reciprocal, so we'll deal with that. Here we have a reciprocal. Okay. So the first thing I'm going to do is I'm going to rewrite this in terms of, you know, one of the primary trig ratios. So sine, cos, or tan. So cosecant is, which one again? If you remember, it's sine. And sine 2x is just 1, 2 sine x cos x. Okay, so we're going to stop there. This side, cosecant x, same thing as I'm splitting up the fraction there just to show you what's happening. And we know that cosecant x is the same thing as 1 over sine x times 1 over 2 cos x. We're just going to multiply them together. And there we have it. Left-hand side is equal to right-hand side. That's it. So remember the guidelines from grade 11. Try to change everything in terms of sine and cos, and try to get rid of double angle formulas. So like if you have 2x, try to rewrite it in terms of x. And yeah, and just, you're going to have to deal with fractions. There's going to be a lot of fractions in this unit. So good luck. Let's move on to the next example. Here we have example 4, proving that cos x is equal to, or the same thing as 1 over cos x minus sine x times tan x. So one side is just cos x, so we're probably just going to leave that side alone. The other side is 1 over cos x minus sine x times tan x. Well, the first thing I'm thinking is, let's rearrange or rewrite tan as sine over cos. And then let's multiply. Remember, sine times sine is sine squared. Now we have two separate fractions here. We can combine them. The denominator is the same. So we can just subtract. And 1 minus sine squared x, hopefully you can see that's one of those trig identities. That's just cos squared x. Go back to the formula sheet if you don't believe me. And this just cancels out. And we're left with cos x. There we go. And that's how you prove. And let's see if we can get another example in. Example 5. Oh, this one looks a little tricky. We have tan 2x minus 2 tan 2x times sine squared x, and this side is just sine 2x. All right, so we'll keep this side, you know, as it is. We'll work on the left-hand side. So the first thing I'm going to do is, well, we have tan 2x and tan 2x. We have two terms with tan 2x. Let's factor them together. Let's do that. And if I factor it, that means I'm dividing by it. So it's going to be 1 minus 2 sine squared x, like that. And we know that, if you recall, 1 minus 2 sine squared x, 1 minus 2 sine squared x, it's one of these special cases here. 1 minus 2 sine squared x. That's equal to cos 2x. So this bracket is equal to cos 2x. So this is just tan 2x times cos 2x. And hopefully you can see that we're going to rewrite tan as sine 2x over cos 2x. And this is obviously times cos 2x over 1. And since these are exactly the same, they will cancel out. In your final answer, you're left with sine 2x. That one was a little bit more tricky. And there we have left-hand side is equal to right-hand side. All right, last example. Cos x minus y. Oh, this one's a little bit more difficult. I remember doing a lot of these when I was at university. They look a lot more difficult than they really are. Once you start simplifying and doing small steps and just keep at it, you'll eventually hopefully get a breakthrough and get it where you want it to be. Okay. So what I'm going to do is I'm going to rewrite this. And you want to pick one side to majorly work on, right? You can work on both sides to simplify. So what I'm just going to rewrite this as cos a minus b and cos a plus b, and just rewrite it as what they're equal to. So if you go back to the formula sheet, I should probably copy this, but that's fine. Cos a plus b is cos x cos y minus sin x sin y. Okay, so same angles, except the first sets are cos, second sets are sine, is a minus sign. And then cos x minus y is cos cos, sine sine again, except now the angles are, wait, no. Oh no, this is exactly the same. The only difference is just plus, right? Yeah. Oh, okay. That's easy. This isn't. This. Look at that. It's not too hard to memorize these. Some of these are not that hard to memorize. Okay, you just have to remember which one was which. So cos x minus y was the one that was cos x, cos y, plus sine x, sine y, and then the cos x plus y was cos x, cos y minus sine x, sine y. All right, keep that there. Let's move on to this side now. Whenever you have tan, try to rewrite it in terms of sine and cos. Okay. Okay, now what? Well, let's common denominator it. So 1 over 1, the denominator for this fraction is cos x cos y, so I'm going to multiply this by that. So this is going to be cos x cos y plus sine x sine y all over, same thing, cos x cos y. In this case, minus sine x sine y. Now, if you take a look at this, they're actually same.